This conference will now be recorded.
So what we learn in yesterday's class, guys? We are trying to understand how an image data can be transferred, right? In convolutional neural network, we started, how an image data can be converted into numbers. Why? Because finally, wherever you are working, your intention is you need to convert into your numbers the data, which whatever the format that is given to send to you. It could be a video data or audio data or any other images data or any other photographic, whatever the data. Data is a data. But what is your job? While we are working on the high level programming and high level projects, you have to implement your packages, programming language, and you need to make sure that you need to convert those everything into numbers. That is what the thing that you have to learn. And deep learning in such a topic is, yes, it has such a capacity that it can be converted in either of any kind of transformation. So whatever the input are received, you should improve in skills in such a way that you should convert those inputs into your own numeric language. Once you are successful into converting into own numeric language, then yes, whatever the things that you want to convert, I mean prediction that you want to do, that analysis, whatever it is required to you, you can apply your own techniques. So what are all those techniques that we have learned from long back? Now we are trying to understand in what situations how to pre-process your data. Exactly. That is what situations means what? One of the situations is a textual data. So you have seen how the textual data will be converted into a numeric and converted into further machine learning process. If I have a image data, then what is the process? Right? So what I said, yes, we may have images in two types. One could be a gray color, one could be a color pics. So gray color pics will always in 2D format, okay, and colored pics always in RGB format, red, green, blue format. So that means what, every image when you are transferring into your system, definitely it will be under these three colors only. If you see any different color, that will be a mixed combination of these three colors. Understanding? If you see any different color, that could be a mixed combination of these colors. So what your system will do according to the inputs, okay, so it will display in the format of pixels, right? If your input image data input will be displayed at the back end of your system in the format of pixels. So what the pixels will carry out? So in each image, how many pixels it contains, okay, how many pixels it contains, in the specific pixel what color is placed, okay, in the specific pixel what color is placed, your system will take those specific value and it will be saved. So the range of that color value is what, between 0 to 255. That is what we have seen in the last class. That means what, every unique color will have some value. That value will be placed at the back end of your system memory. So according to the color, as I say, RGB is in third dimension. So according to the color, that color, specific color will be either any one of the three different dimensions, right? So either it could be in X dimension, Y dimension, or Z dimension. All right. So now if I have a data with the 3 dimension, then how we are going to process? I think I have closed that Excel sheet, but you could have remember that what I said, it will be processed. It will be processed into, I mean, it will be flattened, right? If I say 1 0 1 0 or 1, so this is 2 dimension. So if I convert it into 3 dimensions, that is what, if I get an input of image data, color image, okay. So it will be in 3 dimensions. So the values will be like this: 2, 3, 4, some values. I said now between 1 to 255, so some values will be there. So this process will be converted into what? Flattened. So how this process will be done? So 1, 0, 1, 1, 2. Okay, let me put a gap here, otherwise you will confuse. So 2, 3, 4, 5. 1, 2, 3, 4. 3 and 4. So totally how many values it was taken? That means 12 number of pixels. In that specific image, we have 12 number of pixels, and this will be flattened first. So to get into this flatten, we asked to learn some more additional process, some more additional process. So what is that process? That is what we are trying to do here. Clear, na? So maybe Chaitanya is not much clear, but if you listen to the previous video again, you will get to connect what I am talking. Okay, so let's go for the next one. What are other things are required to learn here? What are other things are required to learn here? So if I open, so look at this picture and tell me, what did you observe? First, what is the first thing that you have observed? Please comment. Tell me, what did you first think that you have observed in the image? Everyone should comment with your answer. What is the, when I open this page, what is the first thing that you have observed? That means what your mind is, what your eyes actually, yeah, what your eyes are observed for the first second. Then, yeah, face with mask. Chetan said face with mask. What about others? Pallavi said mask. Sindhu, what did you observe? So everyone will have a own idea. Sha, she observed T-shirt. Okay, all right. So everyone will have in their own idea, but most of the common points are here. What? Wait, don't say too many answers. Stick with only one answer. You said T-shirt, just keep it as T-shirt. The first impression that most of the people is mask and the T-shirt. But have you noticed that there's a comment on the top, future T-shirt be like? Have you noticed that there is a T-shirt on top, again his face was printed? So later when I'm talking about, you are trying to observe it. Or else when the first impression you have seen the mask wearing, and later you are trying to see what other things are there inside of the pic. So later you might be read this, yeah, the above one future T-shirt be like, and then you will try to read, it's me. You will try to observe who is this person, and you will read the finally Steve. Okay, this person's name is Steve. So that means what? For every moment, your eyes is observing one features on that specific image, and then it will be getting collected into your memory, right? So here, that means what? We are observing only few things, but nobody is observed at the right side bottom. There is a brand mark here. The dear crush something is there from Facebook or something, it is mentioned. You people are not observed, but in some cases this will be more important as well. That means what? A minor pixels also very important for us. You might be have a value on these pixels at the right side bottom, but that could be and most important elements also in some cases. Understanding what I'm talking? So here I am trying to collect those information as well. I am trying to focus those information as well. For example, why should I take? Why should it is more important for me? I'll come back to that one. Let me take another example here. Look out here. This is not looking nice, na? Let's take another one. Yeah, this one. It is coming very late or what for you? I could see still print is, yes, option is not coming up there. Yeah. Now tell me, what did you observe on the peak? Come out with your comment section. What did you observe on the peak? First impression, what you looked at? Dog. Dog contains many things. What other things that you observe? I mean, dog taken more space, right? Okay, you may be seen dog. Okay, only dog. Chair, cloth. Now we are started understanding, sir. You are trying to observe that what other things are there. But the first impression is dog, and second thing interesting, you are looking for chair. And if I ask you what is the color of the chair, then you will look for the what is the color. Then okay, it's black. Then you will look out. Yeah, there is a cloth pink color, which is impressive. Why? Because the background is looks like all black in color. This pink color is more. I mean, your eyes may get. I mean, you will be attracted with that color, right? I mean, the eyes will get captured that exact opposite colors, right? After that, you might see green color outside of the chair and all those things. So here, there will be some minor things will be there. Have you noticed anything like that? Like if I ask you where the dog is actually looking for, towards you, right now. I able to understand what I'm talking. If you see, observe, you could see chair and its little bit shadow as well, right? If you see backside, one leg, chair leg, okay, it's having a little bit of shadow falling out. So you can imagine that it could be some evening time like that. So there you can define like that. So here I'm not going to define into those areas, but I still want to make you understand that there will be some minor things will be there that you will ignore at the first impression. But when I ask you for in more in deep, then you will try to understand. So your mind is started thinking about what are the other minor things are there inside of this pic. Understanding what I'm talking? So here also, I would like to I would like to zoom out those kind of pixels. I would like to zoom out such kind of things. For example, why I should zoom? Why should I consider the minor small things? If I put this application on a CC cameras in general, so in a CC cameras, it is in a traffic area. Imagine. So in a traffic area, how the CC camera will works that you know it, and most of the people moving here and there. Few people are crossing the road. Few people going with the vehicles. So when I'm telling this one, you could have getting an imagination in your mind spontaneously, right? So a person who is moving on the road with a gun keeping in hands. Okay, a person is moving with a gun keeping in his hands. Now, if I take an image from the CC cameras, is that gun can be easily visible? Gun can be easily visible. It's not an easy, right? Because it will be a smaller piece with which will be with a hand size. So if it is in his hands, but what happens in that minor? In that big CC camera image, if the person is moving with a gun, so that means what? That minor pixel is very important for at that moment or not. Now, if I ignore it, what happens? If you ignore it, being a minor thing, and what happens? That the next thing that you know it, what is going to be happen? If you make, if he's if he's like a psycho, so what kind of behavior that he will do on traffic, we don't know, right? Agree? So we cannot neglect in such cases. So that means what? I need to apply an operation on my image data as well, on my image data. So before going to process, okay, before going to process my data, I need to apply an operation. So what kind of operation? So I need to apply a filter. I need to apply a filter and observe closely, okay, observe closely and make them highlighted. Understanding what is the importance of minor features also. Every image will have a major features, minor features. That means what here I mean to say pixels. But sometimes some minor pixels may not be important for us. But sometimes minor pixels also very important for us. So I should not avoid that each and every pixel in an image. If anything is very minor, so I need to highlight it closely. I need to observe it and need to understand how much its importance it contains in the image. I need to understand how much its importance it contains in the image. For example, now people are not listening to anyone and without roaming mask, people are leaving out. You know how much people are doing this thing, right? So if I have real estate from the government, so what I need to do? I need to observe with the closely who are not wearing mask and who are wearing mask, and accordingly I need to make them fine. So I am not going to observe anything. My CC cameras will observe and able to find out, and if he is moving through bike without helmet or without mask, immediately I will trace his number. So I'm not going to do, my program will make such a observations for every person whoever is running on the moving. So if the person to person is not maintaining a social distance, immediately those persons, yeah, those persons will be, those movements will be captured in the camera, and those movements will be observed and will be highlighted at that moment in the then and there, and it will raise an alarm to that respective to, and it will, the next thing is like people will take any necessary action. Understanding how the minor things. So here I need to observe that how much of people are really getting closer, how much of people are really wearing masks or helmets, how many people are wearing really seat belts in the cars also, right? Wearing seat belts in the cars also is one of the minor thing which may be not seen in your actual CC cameras, but we need to highlight it in such cases, right? Yeah. So here, so I need to apply like a binocular camera, not a regular camera. I need to apply a binocular camera. Then only I can observe closely what are the hidden features. Observe closely and make them highlighted, which are hidden features. Right now, which are hidden features. So how to make up, I mean, how to open up those things? To, so first I mean to make a to convert I mean to process such kind of features, to highlight such kind of features, so I need to follow several steps. Okay, so what are the steps? In convolutional neural networks, what are the steps involved in convolutional neural networks? Step 1, convolutional layer. You need to construct first a layer. Okay, step 2, max pooling layer. So what is max pooling layer? We'll talk later. Okay, and then step 3, flattening. FLATTENING, flattening. Maybe I missed spelling here. Flattening. Yeah. And then step 4 is your full connection with the ANN. So what is ANN? That we are already learned. ANN is what? Your artificial neural network. That means you are either it could be a simple neural network or it could be a deep neural network. So what are the differences between simple and deep neural network that we are already learned in the last class? All right. And so according to the situation that you will pick up of your own. So that means what? To get into this neural network, first of all, you need to process properly your data. Okay. So what are the things that we'll do? I mean, what are the steps are how to, as I say, how you are going to zoom those things, how you are make a highlighted those values, in what way? Let's learn one by one. Okay. Let's learn one by one. So here, tell me. So I am showing you one image. Okay, this is one image. Now tell me, did you observe any image here? Did you see and observe and tell me what image captured here actually? Try to understand and tell me. Use your sixth sense and try to observe what actually hidden feature is there. What actually an image is there. Not getting that. Where is the image? So you might be thinking you are looking for an original image. I am giving an input of pixels. Okay, binary image responding that you are and not it. Look out here. Now tell me, what did you observe here? One more.
Smiley, sir.
Yeah, it is a smiley, right? The things which you notice in your WhatsApp. That means what? If I make highlighted, that you are able to understood. But if I don't make highlighted, what happened? Your minds is not able to correct, na? Yeah. So we are trying to highlight it. That is what I'm trying to put up in front of my process. What is actually a an image? An image was, I mean, stored in the numbers, right? Imagine if I take a smiley face and if I convert it into values. So this is what actually yesterday also we have learned the same thing. So what is the dimension of this smiley image now? Now tell me. What is the dimension of this image? Think for a moment, it is a black and white. Sorry, gray color. Don't look for the 3D. Let's put it as gray color. Dimension, can I able to understand? How many rows and how many columns? 7 by 7. Yeah, you should tell that. Why you are very late? Right? The size of the data set is 7 by 7 or not? Why are you thinking so much? That is what I told yesterday also. An image contains so and so number of pixels or not. 900 by 1200 something we have seen yesterday. So 900 by 1200 are the number of pixels are stored in that image. So that is the an input for us. If I make a flattened, so whatever the result that values will comes up, that is the answer. For example, if I make it flattened for this one, so how many features you will have? That means how many columns that will have? 49 columns. Agree? So 49 columns is going to be created with one image. If I pass another image, then again according to the number of pixels, those many columns will be created. Agree? If I pass another image, then accordingly. So I don't know what actually image I'm going to pass. Maybe some 40 by 50 or 5 by 3. I don't know whichever I will pass. Each image will have a pixels. According to the pixels, those many columns will be created. Clear? Now, so now how should I understand? Now in this image, to understand that, you might be thinking that, sir, this is the actually highlighted portion. Why? Because here I could see two eyes, one nose, and a big smile symbol. I mean, so you might be thinking that this is the most highlighted portion because remaining all are zero, so there is no expression. But it's not with all the cases, no? Agree? Every image, I don't know where is the, in which corner, which thing will be highlighted. As you see, if I want to see actually the person's face in the previous page, not here, I close it, but yeah, you have seen. So where I need to observe? On his t-shirt I need to observe. If I want to observe his, what is actually the person's looks like, because he wear cap, he wear goggles, he wear mask. So I don't know how does the person looks like. So I need to observe on the t-shirt. The t-shirt makes very important, right? So here I don't know, because my whichever the inputs I see, I need to observe everything from all the angles, all the pixels throughout your image. I need to observe everything from all the pixels. So I need to give a chance to highlight all the pixels. Agree? I need to give a chance to highlight all the pixels because I don't know which image may have, which image I have an importance of which pixels. Agree? So for that purpose, what I will do, I will create a, in my step 1, I will add here a feature detector. Feature detector. Feature means what? Actually column. Detector means what? Identify. Agree? So what I am going to do, as a part of the process, I will take, so here 7 by 7. 7 by 7 is your actually input. Sorry, yeah, input. So I will try to process with the 50% of the information. So 7 by 7. If I take 50%, what does it mean? 3 by 5? Sorry, 3.5 into 3.5. So I cannot take 3.5 pixels size. So what I will do, I will take 3 by 3. Is it clear? 3 by 3. So what I will do, initially randomly I will take any one as 3 by 3 here. Yeah, this one. I will take this 3 by 3 values here. Randomly I will choose any one of the 3 by 3. Understanding what I'm talking? So this is how I'm going to create a future detector. From future detector, I'm going to convert. Now this is going to be your future. So let's write as FD. From this future detector, I'm going to create a future map. future map. Okay, so how it will be calculated? Now, first of all, I will take a chance by taking the first 3 by 3 set here. So I'll make as for time being like this. So I will multiply with these values with these values, not like your regular multiplication. I mean a matrix multiplication. It's your normal multiplication. So what will be the value? What will be the answer? So 0 into 0, 0, 0 into 0. That means here first row. This one. 0 into 0, 0, 0 into 0, 0, 0 into 1, 1. Sorry, 0 into 1, 0 again. Sorry. Plus again 0 into 1, 0, 1 into 0, 0, 0 into 0, 0, again 0. So all these three zeros means what? These values also equals to 0. So what is the result? 0. Okay. Again. So I will take the next layer. I will make it as no color. And what will be the next 3 by 3? This is going to be next 3 by 3. Again. So again I will multiply. So first 3 zeros, obviously this line will become 0. Next 3 zeros, 1 0 0. So here I will give 1 into 1. So I have 1 1. I have one value of 1. And remaining 2s are zeros into 0, 0 into 0 becomes 0. Again 3 zeros. So whichever the value that you multiply, still you will get 0. So what is the addition of the total? These 3 lines and 3 lines, you will have only one value. So that will be saved here. Understanding? It is a typical calculation, but try to understand. Okay? Even if you read in the YouTube, or even if you read in the any other web, what is it, web links, you cannot understand this one. For me only it was taken a long time. Okay? Try to follow it. Again. So again I need to jump this one from here. No fill. So next one is what? Again this one. So here if you see, all values are zeros. Right now this blue color shaded. So obviously your result will be definitely is a 0. Agree? Again I will remove this color, make as no fill, and again I'll put it here. Now I given as red color. All right. Now, do we have chance anywhere as 1? No chance, no? Because first 3 is zeros. Definitely is first 3 becomes a 0. Second 3 is I have 1 here, but I have 0 here. So waste again 0. Again 3 rows, 3 zeros, 0 1 0 0 1 1. But anyway 0 again. So what is the resultant? Again 0. Okay. So I'll remove this color again. This part also done. So what is the left? This part. Now is there any value you will get again? First layer 3 zeros. So this is 1 we have, but these 3 values are zeros. So gone. Again second value is 1, but in the second value in this future detector I have 0. So again you will get 0. Again in the third row all the 3 rows are 0. So obviously you will get again a 0. Clear? After that this thing is cannot movable because the number of columns are closed. So where it will go? This set will go into the next 3 rows. Again like this. Understanding what is going to be happen? Now again I need to calculate. I need to give a values like this: 0, 1, 0. Some values will be there. I don't know what values. I'm not calculating, but I'm telling you some values will be there. Like that. Like that. Can you guess and tell me what would be the size of this future map? Can you guess and tell me what would be the size of the future map? 5 by 5,
7
na?
by 5.
5 by 5 you get, not 7 by 5. Because here also, when you go for the next row, next row, next row, you will be stopped at this position, right? So you will filled with the values with the 5 rows only. How it was happened with the columns, the same thing is going to be happen in the rows as well. So you will get an answer as what? 5 by 5. So this 5 by 5 is your future map. The story is not end up, okay? Story is still there. This is what is going to be happen. Clear? So here, if I do this thing, this entire thing, so yeah, this is what I mentioned here in my next sheet. How did I process? So I chose them randomly with 3 by 3. That's what. So 50% you should take generally. As I say, 3.5 by 3.5. So we cannot take 3.5. Either you should go with the 4 by 4 or you should go by 3 by 3. So I'm going with the 3 by 3. All right. That is a, I mean, I say general process that people has to be followed. Okay. After that, when I calculate entire this thing, yeah, you will see these values. This middle thing is the color value. So these are those inputs which I told, like first three from this one, and this is my future detector. So what is the result? 0. That is I stored here. I'll make like this. There's a lot of values. Okay. So this is our 5 by 5 set. I multiplied and I stored like this. So what is the result? That result as I stored at this here. Just look for a minute and tell me that you are followed or not. Leave about this max pooling. I'll come back to that point. Yeah, so this is our result, 5 by 5. So this bottom thing, everything is the result of each and every set of matrix multiplying with your actual future detector. Clear, everyone? Just let me know. I mean, look at the values: 0, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 1, 0, 4, 0, 1, 1, 0, 4, 0, like that. 5 by 5 multiplication, everything. Okay. So what I said here, actually, I have taken the randomly basis. This one as if, I mean, randomly I have selected one future detector. But if I make such only one future detector, chances are there it is going to be biased or not, because you are making wantonly centered somewhere with a 3 by 3 set. So I need to take multiple future detectors. Requirement is there or not? Understanding? Maybe if I take this one as future detector to multiply, maybe I will get a different set of matrix or not. Different set of future map will be generated or not. If I take another 3 by 3 set as a future detector, if I select another 3 by 3 set of future detector, definitely I am going to get a different future map or not. Agree? Now the question is, how many future detectors should I select now? So there is no specific number. If you put a permutations and combinations, you will get a large amount of numbers. So you can take some number as per your idea. Like if I take 15, for example, if I take 15 feature detectors here, okay, so what will be your answer? I have written my notes, everything here. Let me open. This makes more clear here because I mentioned everything step by step. These are all things that you know. I told you just with an Excel sheet. I copy pasted here. Okay. And if I apply one feature detector, one feature map will be generated. Okay. So how much? So let me read out here. Yeah, here feature detector will be selected on a random basis and it will be multiply all the possible segments from the input matrix. So what is segment here? The 3 by 3 set which I'm taking from the input image. That means what here? 0, 0, 0, red color box. Okay. So I'm calling them as a segment here, one segment. Okay. So it will be multiplied with all possible segments from the input matrix and it gives what? One feature map. How much filter size can be taken? It can be taken by random basis, as I said, suggestion 15%. Okay. For one filter, if we got one feature map, that is what? 25 possible segments. For one filter, we got one feature map. So 25 possible segments made here with the values, 5 by 5 values. Okay. If I apply 15 filters, so how many possible values you will get now? 15 into 5 into 5. So you will get 375 pixels are generated or not. So you can ask me a question of why we take 15, why can't other number? Yes, we can take any other number. We can take n number of filters, but it will become more and more heavy complex algorithm also. That is also you need to keep it in your mind. Okay. You can go with a higher number, but what happens? It will become more and more highly complex algorithm. So you need to control those things also. Keep that in mind. Okay. Yeah. Now come back. That means what? That means for all your minute values, you are making into a big image in the form of feature maps. Yes. Why? Because earlier, actually, we have 7 by 7, 49 columns only. Now, how many columns are going to create, guys? How many columns are that we are going to create? 375 columns. If I don't make highlighted, your original is 7 by 7, so that is what 49 pixels on be formed. That means 49 columns will be created. But once make it is highlighted, right? Every portion of my image I am making highlighted. Okay. So I am trying to make highlight and equalized, and I am creating a more number of columns with a given information. So like that, yes, like that you are making 375 pixels. So your step 1 is finished. Clear? So how the first convolutional layer is getting started here? So convolutional means here the meaning like now you are looking for more closely. That is what the meaning. More closely, more. I mean you are using like now microscope, binary scope, like that. Those things you are making use and you are observing and making highlighting. That is what the meaning here. The convolution layer. Now the thing is, after looking closely, is it really important to make such a high number of columns? That's why we'll apply again max pool layer. Understanding what I'm talking? So again, you are observing a max pool layer. That means you are making zoom in. Okay, in a specific image, you are making zoom in, and what actually important things that you are finding out, only those things you are making pulling out. That's what max pulling. That means where I could see a max value, I am trying to take up only those values into consideration. Understanding what is max pool here? Okay. After highlighting all the values. I will try to take, okay, where I could see max values from overall pixels. So I'm going to prioritize here based on the values, based on the pixels, whatever it contains. Okay. So how it is going to be happen again? So let's a simple example. If I say, yeah, if I observe a person closely, let's imagine that there is an image in front of you. Okay, the person's face, maybe whoever your friend's face. Okay, so if you try to observe him, so you will look many things from his face. I mean, if a person is male, how much of beard he is maintaining? Okay, if he's a female, if she is a female, and what is the? I mean, what kind of color that she is using for lipstick or for eyebrows? Agree? And what kind of? I mean, how she is maintaining herself? So these are things like that you can observe closely, right? So out of those, you will take only the important things that you want. Agree? So you are out of total, you are making pulling out the maximum information. So that is what here again max pooling layer. So how it is going to be happen? Look out here. So imagine that in the previous exercise I have 5 by 5 set, right? Without, I'm talking about if I have one future detector, obviously you will have what 5 by 1 5 by 5 set. If I apply 15 future detectors, then you will get 375. That's the story, right? So I'm not talking about total, but I'm taking still as one. So again, how you are going to take up these values? So again, from the 5 by 5, I will take 50% only as pool size. So this pool size is now 2.5. So anyway, I cannot take 2.5, so I will take 2 by 2 only, like this. So what I will do, look out here, from 0, 1 and 0, 1. So the first 2 by 2 set contains, what is the max value here? 1 now. So that 1 will be stored here. Where? In the pooled future map. In the pooled future map. Again, this time, it is not like in the previous set. It will be completely jumped to the next set. Next 2 by 2 set. That's why I made with color, blue color. I think I have an Excel. Let me check in my Excel it is there or not. Not there. I thought it is there, but it is not there. Okay. But okay, let's understand here. So it will take the next 2 by 2 set. In the previous exercise, it is not like that. It will go with the 1 by 1 column. Now it is not like that. It will go with the next complete set. So next set is what? 0, 0, 1, 1. So what is the max value? 1. So the 1 will be again stored here. You can just guess out. Yeah, I'll give a space here. Now tell me, for the first set, what is your max value? 1. From the next set, what is your max value? 1. For the third set, that is yellow color. So yellow color is moved to right side, even there is no column. But still, yeah, I will take here consideration. So what I will? 0. Again, next set. From the next set, what is your value, guys? I will highlight like this to make understand for you. Now tell me, what should be my value in this cell? 4, na? Yeah, very good. Next one. 2. It's not like your previous set. It's not, I'm telling you again, it's not like your previous set. It is directly jumping for the next set. In the previous thing, in the future map, what happened? Future detector is like step by step it is going. Every line, every column, every row is taking the charge. Now here it is not like that. It is moving completely. Now, yeah. So your value is 2. So what's the next here? 1. Here 0. Here 2. Here. Let me check here. I forgot the set here. 1 second. This is gone. This is gone. This is gone. Yeah, only 1. Right? This is what actually now your pooled future map. This is how the values will be placed here. All right. If I put with the 15 future detectors, so how many pooled future maps will be generated? 15. No? Like this. Look out here. Now you're able to follow. Here you will have 15 future detectors. So every future detector will have one max pool layer. So 15 max pool layers. So the total number of columns here is, what is the size of the max pool layer now? 3 by 3, na? You have selected the answers 3 by 3, right? So yeah, 15 sorry, 15 max pool layers into 3 by 3, right? So 15 3s are 45, 45 3s are 135. Yes, 135 pixels or columns will be created. Pixels will be created first of all. I did not flatten it. If I make a flattened, then it will be created 135 columns. Now coming to that actual point, now how the process is going to be happen? Yeah. So how it will be processed? I mean, how to flatten it? It's again when you write that Python code that will be taken care. But you understood how the 135 pixels have been generated in this set. So now what we will do? We'll make flat and each first layer, I mean first max pool layer, whatever the 3 by 3 set will form, yeah, I will put in this order. Just a minute, guys. Yeah, I will put this one. This is my first max pool layer values. Now everyone should be able to follow. Yeah. Now I finished with one image. Okay. First image. First image. And yeah, one future detector is closed. Now, sorry, one max pool layer is closed. Now, second max pool layer definitely will have some values or not. So I will start adding second max pooler layer values. Understanding? So like that, how many times I will do this task? 15 times. That means what? So how many columns is going to be created? 135 columns is going to be created. That means every max pool layer is going to be flattened till last 15th max pool layer, from first to 15th. Now it's clear, everyone, how the process? Yeah, this is what is going to be happen actually. So this entire thing will take care of Python. Don't worry, the package Keras will take care. But how you are writing, I mean, how the calculation is happening at the backend, that is most important to know here. So everything is what here? A simple mathematics. A simple mathematics between creation of one layer to two layers to, I mean, future detectors, future maps, from future maps to max pool layer. The next thing is what? As I told, flattening. If I write a simple flattening function code, it will take care of converting to your input to columns. Once your x values are ready, then what is your next job? Yeah, start connecting with your ANN. That means your sequential code. That is what I said. Now sequential code. Right? You need to write the sequential code, and then what other thing is it? Model dot fit that we are learning in the Python. That is going to be same story. Is it clear? Everyone is clear till now? What have we learned? What have we discussed? Chetan, Chetan is left. Then could not able to understand what is happening here. He need to be listen again from the first video yesterday's. Then only he will get know what's happened today. Any questions from both of you? Clear now, guys?